Hello students, in this video we are going to consider two problems that combine the concept of annuity and the concept of compound interest in a period when there are no payments. The problem says this: Scott had saved $560 per quarter for the last 3 years in a saving account, earning 5.2% compounded quarterly. He plans to leave the accumulated saving for 7 years in the saving account at the same rate of interest. And the first question is, how much will Scott have in total in his saving account? And B, how much will be interest? So we are going to compute also the interest. So let's focus first in the first question. How much will Scott have in total in his saving account? So thinking in this problem, we are thinking an annuity that appears like this. There is a period of time when there are an actual annuity, so there are payments that Scott is making every quarter for a period of 3 years. And after that will be 7 years without any payment. And we want to know how much Scott have here at the end. What will be the accumulated value, the future value of all this period here? Okay, so if you are going to solve a problem like this, think in the first period when the payments are made. In this period of time, we know the interest, that is 5.2, we know that the payment is 560, and we also know that the compounded period and payment periods are quarters, both of them. Okay, so what information we have in this part of the problem? We have the payments 560, that the interest is 5.2% compounded quarterly, the number of compound periods or the number of payment periods, that is the same, are 4 per year. So we know this, and we know that the time is 3 years. So I'm thinking only in this part. We are going to compute the future value of this part, and the future value of this part will be the present value of the second part of the problem, in which Scott is not making any payment. So in the second part, there will be only compound interest working. So let's compute the future value of the first part. The future value will be Sn equal R1 plus I to the power n minus 1 divided by I. Make a substitution, 560 will be here. I, the periodic rate of interest, will be 0.052 divided by 4. And n will be 12. So making the substitution of all this value, we have this. And then use your calculator. 560, open bracket, open another bracket, 1 plus 0.052 divided by 4, close bracket, to the power 12 minus 1, close the bracket, and then divide it by the amount at the bottom. Okay, if you do that in your calculator, the answer is 7,221.92. And this will be the value that Scott has at the end of the annuity. And I say at the end of the annuity because this is the only part in which actually we have an annuity. The second part of the problem, we don't have annuity. This value here, 7,221.92, will be the value of the payments at the end of these 3 years. For computing the value of this amount 7 years later, so what we're going to use is the formula of future value. So we have that the present value of this second period of 7 years will be 7,221.92. The interest in this part could be different, but in this case it's the same. They tell me that it's at the same rate of interest. So it means that R equals 5.2% and there are no payment, but here is important the number of conversion periods per year. The number of conversion periods per year is 4. So it will be 4 conversion periods per year. So the number of conversion periods is what we use in a compound interest problem. So the number of conversion period will be the time, that is 7 years, multiplied by 4 periods per year. So it will be 7 times 4 equal 28. Okay, so we have that this 28 is the number that we're going to use in the formula of compound interest. So no annuity is a compound interest problem. So it will be the future value of this will be the present value 1 plus I to the power n. And then just make a substitution. 7 to 21.92 open bracket 1 plus 0.052 over 4 to the power 28. So I type here the power. Type equal in your calculator or make this in your calculator and the answer will be 10,368.53. That will answer the first question. So we can say that the skull will have 10,368.53 in his saving account after the 10 years period. So these 3 years and these 7 years. For answering the question B, how much will be interest? Will be the future value, the amount at the end, minus the contribution of Scott. But Scott have contributed only 12 times $560. So you can say that the interest will be equal to the future value minus the contribution, or better, the future value minus n times r. And it will be the number of payments, r is the amount of payments. So it will be 10,368.53, that is the future value, minus 12 times 560. Scott have made 12 payments of 560. So made it in your calculator and you find the interest is 3,648.53. Is the interest that Scott has earned in these 10 years. So the amount of interest included in the future value is 3,648.53. So that finished this first problem. Let's solve a second problem when we have this combination of periods, an annuity interval and an interval when there are no payments. This second problem says, for the last 6 years, Joe Borelli has made a deposit of $300 at the end of every 6 months, earning interest at 5% compounded semi-annually. If he leaves the accumulated balance in an account earning 6% compounded quarterly, what will be the balance in Joe's account at the end of another 10 years? So again, we are thinking in a situation when we have a period of annuity, a period when we have payments of 6 years in this case, because Joe Borelli has made payment for the last 6 years. At the end of every 6 months, so these payments are semi-annually. And it's compounded also semi-annually, so this is an ordinary simple annuity. And then there are 10 years when there are no payments. So after the 10 years, we want to know how much we have. We solve first what is the future value of the annuity, and this future value of the annuity will be used as a present value of the second part, a present value of the compound interest part. Okay, so let's think. In this first part, we have that the payments are 300. Also, we know that the interest in this at the beginning is 5%, so R equal 5%, and it's compounded semi-annually. So there are 2 periods per year. So there are 2 payments per year. M equal 2, and the number of payments will be T times N. T, that is 6 years, multiplied by 2 equal 12. So make a substitution of all these values in the formula. So this R is 300, this I is 0.05 divided by 2, or 0.025, and this N is 12. So use your calculator and you will notice that the answer is 4,138.67. This value will be the present value in the second part. So for computing the value of the account 10 years later, what we are going to do is using this as a present value. So the final amount in the first interval will be the present value of the second part. So the present value will be 4,138.67. The interest in this second part is different, so it will be 6%. So R equals 6%, and it's compounded quarterly, so there will be 4 periods per year, 4 compounded periods. These compounded periods is the one what we want to know in a compound interest problem. How many compound periods? It will be 10 times 4, so it will be T times N equal 40. And so that means that the future value will be 1 plus I to the power n, or better, 4,138.67, open bracket, 1 plus 0.06 over 4. Obviously, you can type 0.015, that is the result that you get when you do that. And this to the power 40. Do this in your calculator and you get the answer, 7,507.62. And this answers this second question. Okay, and with this second question, I finish this video. Thank you.